Dear friends, I'm here and today I wanted to tell you about this machine learning application that I have created, which can predict the direction of your high yield corporate credit ETF from BlackRock iShare. So, if you know that this HYG ETF, okay, it is a high yield ETF from BlackRock iShare, and it contains below investment grade bonds. It is an ETF, okay, and so actually I wanted to see whether a machine learning model can predict the direction next day of this ETF, okay. Just see what can happen if you know whether the ETF will go down next day or whether it can go up next day, okay. So it's a big advantage for portfolio managers as well as risk managers to know that. For portfolio managers, it is obviously advantageous, okay. They can take long and short positions in the ETF. But for the risk managers, it is also advantageous, okay, because they manage risk, okay. And to manage risk, it is definitely a good idea to know, okay, what are the odds, what is the probability that your ETF in the portfolio, whether it can go down or whether it can go up, okay. So hang on, we will go through it and I will explain you whatever I learned from this project of mine, okay, and what my model can do, okay. It is a good revelation. So that was the objective of this project, okay. And now we move to the next point, okay. So this is a machine learning model, okay, machine learning model. And what does machine learning models need? Okay, they need data. This is a labeled, okay, supervised learning method, and I have used XGBoost model to train my data set. Sorry, to train my model actually. And initially I thought, why not pick huge data? Okay, usually for ETFs we have like a lot of data. Most of these ETFs like HYG or JNK or other sector wise ETF like XLE or XLK, MGK, okay, these sectoral ETFs, or even Russell Value Growth, or all these ETFs, they were launched long back, like 20 years back, and there is a huge market data available, okay. So someone might think, okay, more data equal to more accuracy or a better model, okay. Obviously I will think that, okay, I have more data, I should have more, should use all that data. I tried that for 15 years of daily returns, okay, or even monthly returns I tried. But you see, the problem is that the markets are non-stationary. This is a time series data of a financial variable, okay, financial returns, and they are non-stationary. The standard deviation or volatility does not stay same, and it changes. So that's why you see, after COVID-19, the volatility before COVID-19 was different, and after COVID-19 in 2020, the volatility was different. So the volatility regime itself changes. The model interactions or the relationship between variables itself changed. Okay. So for example, okay, if you know the VIX index, VIX index, it is a volatility index, and it is a very instrumental, okay, very useful feature to predict the direction of my HYG ETF return next day. So this relationship between a feature, okay, which is the source data set or independent variable, to the predicted data set itself can change. So that's the point, okay. So how do avoid that? Okay, how do avoid non-stationary markets or two different regimes in the same machine learning model data set? So for that, actually what I did, I chose recent 5-year periods in which I found that the volatility was there was less variability in the volatility, okay, let's say it like that. The markets were pretty calm after COVID-19, okay. There was lots of money printed, and there was lots of quantitative easing, and yeah, I found that XGBoost is quite good in this type of market, okay. So yes, so 5 years data period, okay. So let's remember that. So now we move to the next point, which is the data sources. Okay, you when you are trying to predict, I mean, when you are trying to create a machine learning model and trying to predict direction of one ETF, okay, what's the important thing? Okay, you need data, and where does it come from? Okay, for this machine learning project, I did not get any paid subscription data. Okay, all this is free data available from Fred. They can give you interest rate data, okay, 2 month or 10 year or 20-year data. You can easily go there and download the interest rate curves, okay, full interest rate curves at various tenors. So interest rates are important feature to predict ETF directions, okay. So they are important features. They are macroeconomic features. They affect everything. They affect ETF, they affect financial markets, okay. And what do you need apart from that? You need ticker data. So what I'm trying to do here is download all my features. What are my features? My features are sectoral ETFs, okay. uh, since ETF data is freely available from Yahoo Finance and Alpha Vantage, okay, I have written Alpha Vantage here because for some reason my Yahoo access has been blocked because I I triggered a lot of API calls for Yahoo Finance, and um my it got deactivated from their end. But the main point is that, okay, this Alpha Vantage gives you like 25 API calls in one day. I You can use that for 25 tickers for you can yeah, 25 tickers. And the main point is, if you have Yahoo Finance, good. No, nothing better than that, okay. They have very unlimited range of tickers availability. So yes, so we have covered till now the objective, data period, and data sources. Now we come to the next point, okay. Also, I wanted to show you how I downloaded data from Alpha Vantage. So this is a pseudocode. I will also show this code in my, I have also added this code in my, what do I say, the GitHub library, okay. You will find it in GitHub library. And this Fred data, if you want Fred data, you can just go there and download. Just go there and write GS10, GS20. So this way you can download interest rates and ticker data. And apart from that, if you want OECD indicators like PMI, machine, what is the manufacturer purchasing manufacturing index, purchaser manufacturing index, then you can go to OECD site, okay. So there are many versions of PMI available. I have also used it as one of my feature, okay. You can go to that site and download it. So that's how you can get free data. If you can get access to paid data, then okay, that's also good. And now, okay, so this is the main tickers data I downloaded, okay. Okay, so your predicted variable is the direction, okay, whether the ETF HYG will go up or down. And what are you trying to predict it from? Okay, you have a model, XGBoost model, machine learning model. And how would you train that model? You need supervised learnings, okay. And you will get these returns, these tickers, okay. So I have downloaded these sector wise tickers. Sector, these represent different sectors. There is one is the energy sector, okay, and one is the financial sector, one is the tech sector. Tech sector is like you can use it like a growth factor, okay. Because if you see Amazon and Microsoft and Nvidia, okay, so you can call them growth stocks. And now there is a financial is like very stable. If you see a stable return in the financial sector, then it and then there is energy sector, and there are market factors like SPY is a broad market factor. It is a broad market because it has 500 securities in it, 500 biggest stocks in the US market. It represents your equity risk. It represents equity risk. Then there is a credit factors, HYG. And so you see, this is my predicted variable here, okay. And there is one replacement could have been JNK, okay, which is pretty similar ETF from State Street. They contain junk bonds, okay. Junk bonds are nothing but the bonds who are below investment grade. If you remember, the lowest investment grade rating is triple B. And so these ETFs, they have bonds whose rating is below that triple B, okay. So that's the point. So this is my predicted variable, and now interest rate factors like these again, these are some ETFs through which you can get the direction, at least direction how the rates are moving. Okay, and now the market will so try to understand what I'm trying to say. I'm creating my feature set, I'm creating my probable feature set. I have downloaded all these ETF returns, and now this is VIX is very important. VIX has a very direct correlation with the high yield ETF returns. Okay, what is this? It is market volatility, it is the fear gauge, and it is very important. Suppose if the VIX is high, then okay, think like that. The HYG ETF return will be low. Okay, if the market volatility is high and there's a fear in the market, okay, everybody trying to sell at the same time, then okay, what will they sell first? Okay, your HYG ETF, its return will go down. It will have negative returns. Okay, so negative correlation. That's what they're trying to say. Contrarian indicator. And then there is a consumer discretionary. Okay, and so suppose there are many sectors, like would you buy a Tesla in a down market? Okay, when there is a recession, people usually don't buy at least middle class don't does not buy Tesla in a recession. Okay, and they may order fewer things from Amazon also in a recession. So that's the main point. So this is again one of the risk factors, or what you call feature, that consumer discretionary. Okay, XLY, this is again one ETF. And so why did I use ETFs? They are freely available, data is available, and we can use that as like features. They're using their returns as features. Now this is defensive sector. Again, one more ETF. So utilities, we need electricity whether there is a recession or not, whether there is any downside or not. Obviously, we need electricity, gas, water. People cannot live without it. Okay, these companies will always make money, whether there is a recession, high growth environment, stagflation. They will always uh, utilities will always make money. Okay, and then there is a value factor. So you might have seen that some firms, they have value factor, like how will I give you one example? For example, see the some coal companies in different geographies like Adani company, or sorry, I don't have any good example now, but value factor is like the price is less. Okay, price is less and you can get it at a good price. And this is main differential between a value factor and growth factor. Growth factor means you think that the company will grow a lot in the future, like Tesla. Okay, if you remember, in the initial period, Tesla had very little revenue, they were selling very few cars. Okay, but then the price was sky high even then for the Tesla. And if you see the early stage companies, which like uh, some tech stocks, even you see Nvidia today. Okay, Nvidia is a growth stock because its price is very high, and its revenue may not be that high. Okay, so when the future growth perspective comes into the picture, okay, then the price goes much more than the actual revenue that the company is generating. So those stocks become growth stocks, and the value stock companies are usually well established companies. Okay, and usually they people see less growth potential in them, and that's why the price is low. Okay, so these are the other features. And then mega cap stock, like again, this ETF contains very big companies. Okay, just trying, you see what I'm trying to do here, just trying to gather some factors or some features through which I can derive more features, more compound features to use in my model. So I'm just going through my data, my underlying data of my model. Now the mega cap growth. So mega cap growth means, again, mega means very big, right? These are huge companies, and their growth, see, again, Apple, Microsoft and Google, these are huge companies. They are growth. Okay, price is higher compared to the revenue. And then mega cap value. Okay, price is low compared to when revenue. I mean, they are established companies usually. Okay, and they span various sectors like financial, healthcare. Financials we saw earlier, okay, healthcare. The main point is that there is very little innovation in these sectors, okay, and even in healthcare and financials, yes, valuations are pretty established. The prices usually don't skyrocket a lot, prices of stock, I mean. And then the investment grade liquid, so this is again one ETF, okay, all these are ETFs, okay. And this is very contrary, very different from my HYG or JNK ETFs, okay. So this is investment grade ETF, investment grade ETF. It like above triple B. If you remember, triple B is the rating, okay, lowest investment grade rating. Okay, now you see what is my seed data. I downloaded all this ticker data. Now what did I do with that data? Okay, obviously I need features. How did I use this data? You must be asking yourself. I created very many different types of features, 60 plus different features I created, okay. And how do we, why it is very important to create compound features, you might ask, okay. So compound features are important because if you see the hedge funds, how do they make trades? They simultaneously buy a low valuation security or maybe a value stock, and they sell a high valuation security, maybe a growth stock, okay. So trade is always binary, at least in the hedge fund universe. So you're always looking for binary signals at two different ends, okay, extreme valuations, low valuations, or high momentum, low momentum. You try to trade at both ends, okay. Or if momentum is your factor, you want to short low momentum security or ETF, or want to buy high momentum ETF, okay, to try to so that's how we magnify our signal. If you say that, okay, I want to buy only high income ETF, then it may not magnify your signal a lot, okay. So that's why there are all these factors come in binaries, okay, high versus low growth, low versus high momentum. And there are also interaction features. So VIX also, volatility index, okay, volatility index interacts with the with broad's stock market return like SPY. They interact, and there are also sector momentum, so very different, where you can do a lot of different types of feature engineering, okay, lots of, there is a lots of scope. So I will tell you how we can use this feature engineering to come up with to determine what are the most important features for your model. So that stage will come later, but please stick with me for a while. So these are the some cross asset features. If you subtract SPY minus high yield grid returns between high yield credit versus SPY, then you will see divergence, okay. SPY is again a broad market index, and HYG SPY is a stock market index, and HYG your high yield ETF. And there is equity credit momentum gaps, okay. If you subtract the return of equity index and subtract return of like credit ETF index like HYG, then that is also a feature, okay. Style rotation, growth versus value stock, okay. Cyclical versus defensive, I told. So cyclical stocks are nothing but stocks which whose value increases in up cycle, like in high growth environment, cyclical ETFs, they gain a lot of value. And defensive stock, as I told you, like consumer non-discretionary, they retain their value. So like utilities and water, these are defensive stocks, they will keep their value even in downturns. And cyclicals are like ETFs or stocks whose value go up and down with cycle. And then there are VIX interactions, VIX plus multiplied by return, VIX multiplied by spread, fear performance relationship, regime detector, risk on off, okay. What is risk on off? Okay, if the VIX is very high, then obviously it is risk off. You might want to sell risky ETFs, risky securities like HYG, okay, and buy liquid LQD securities. So that's the point. And volatility regime flags, okay, if the volatility too high, volatility too low, things like that. And then there are mean reversion indicators, like so these are some of the screenshots of the feature engineering factors that I created. So VIX momentum 1 day, okay, it is the return of 1 day, and VIX momentum 3D is equal to VIX return for 3 days and 5 day. Okay, so you're trying to determine, okay, what is the momentum, what is whether it is increasing or decreasing, whether the price is increasing or decreasing. That's the meaning of momentum. Okay. uh, yeah, so that's the meaning of momentum. You're trying to see whether VIX rose in 1 day or increased in 3 days or 5 days. Okay, and then yeah, so then now there's a VIX acceleration, and now it is the second derivative of VIX, okay, or the first derivative of momentum, okay, rate of change of your momentum. It is again one of the feature that I used. And then there is a growth versus value, okay. So this is if you see this, IWF is your growth index, sorry, growth index from Russell, okay. IWD is your value index from Russell, and there is a mega cap minus small value cap, okay. So these all these features comes in the binaries, okay, that we create a compound feature by taking those binary features and doing a subtraction. So this is the simple rule of thumb if you want to remember for a compound feature. And there are more such features. You see, I did a lot of feature engineering, value versus growth, okay. You, it may be more straightforward. And then there is economic optimism, okay. If you are some of these ETFs, if they are making money, okay, good returns in them, then there is economic optimism. There are cycle indicators as well, equity credit diamond. So this feature I think we saw earlier, SPY return minus HYG return, okay, equity credit divergence, equity credit, and then HYG versus JNK divergence. And so please ignore this feature. I don't think it has a meaning. It was anyways removed in the later stages. Now, okay, now you have done your feature engineering. Okay, you have derived your features now based on these ETF returns. Now you want to scale them. All these features you need to scale. So what happens if you don't scale them? If you don't scale your features, then suppose VIX, if you see VIX, it has 0 to 80 range, okay, 0 to 80. And most of the ETF returns, like what, how are they daily returns, like 0.1%, 0.2%, okay. See the scale difference between 0.1 and 80, okay. So if I just feed my ML model these 80 values of VIX and 0.1 values of any ETF return, what will my model think? Okay, VIX is very important feature, okay, and let's give it highest weight in my model. Let's, if I'm using XGBoost model, then it will at max, at all the trees will use this feature VIX, and all the leaves, most of the leaves will try to use this feature actually. So so yes, it will be very wrong, because all, see, all the features should get I mean all the relevant features should get some weight, okay. And I don't want to use uh, a feature which is being used more just because it has high value. So the VIX come in this web version only, right? So that's why I used this scalar. It is a standard feature. It is a standard available in the scikit-learn module. You will find this module in the scikit-learn, and you can use it. Then there is the next point is of multi-collinearity. What is multi-collinearity? If two features are related, if they have more than 95% correlation, okay, then if they have 95% correlation, then I don't want to keep correlated features in my feature set, okay. It won't make sense to keep correlated features in my feature set, uh, because multicollinearity can distort weights and results of these machine learning models. they can really distort and make the model create false predictions and results. So, so that's why I have removed features which show multicollinearity. Now comes the next point. So now you have seen the feature engineering, you have seen the scale. I will scale all my non-categorical features, and now the multicollinearity. Multicollinearity means sorry, I will move to the next. I wanted to show you my features. Let me show you my features. Okay, wait for 1 second. Okay, perform feature engineering. Okay, so these are all the features that I created. You see, and and the compound features are in the end. These are the same features that I showed you, right? These are the same features that I showed you. And there are also some binary features. If you see, these are the binary features. One thing I wanted to do was to combine many of them and to use one hot encoding. But I could not do this time, but maybe we will touch it later. Okay. So now you must be thinking, okay, now I have like 102 different features. So how will I choose the most relevant features for my model? Okay, my model has only like 5 years of data, and how see think like this: how many data points or rows or records I have? Like I have like 1,300 records. Okay, 1,300 records, and I will like to choose 70 or 80% of my model for the training and validation data set, and only I want to keep like 30% or maybe 300, sorry, 300 records for testing, so final testing, to see how my model is working. Okay, so that's how it works. Okay, so my data is not, I don't have lots of data, so I want to keep my features less, manageable feature count. And so it is important to know which ones are important. Simple as that. And there is a rule of thumb that for each feature there should be at least 10 records. Okay, each feature there should be at least 10-20 records. uh, okay, permutation important. So these are my various so I used four methods to determine importance of a feature. Okay, four methods. I uh, i could have used correlation, but I personally found all these four methods to be more holistic, because they also capture non-linear interactions. You see this mutual information, it contains non-linear interactions and this f static. So I wanted to be more holistic and more thorough in this feature selection process. So what is a permutation? Let's go one by one. You select one feature and you shuffle it. Okay, randomly shuffle it, and let's see, you see how the performance of the model drops. So it is straightforward. Then the recursive feature elimination, you eliminate one feature and see, okay, does my model break, or how much is the degradation in the performance of my model. So that is recursive feature elimination. Eliminate features one by one and see how the model behaves. And then the mutual information, it tries to see it tries to see the relationship between the predicted variable and the feature variable. So so that's the point. So that is the mutual information. And then there is the f statistic. Okay, so it tells you whether your feature, okay, whether it has, how much is the variance difference of this feature in two groups. One is your one is your down movement of the HYG. Okay, one is the down movement of your ETF, and one is the up movement. Okay, suppose you choose VIX feature. Suppose VIX is a feature, then you would want to know, okay, what is the variance of my feature in the down movement, and what is my variance of my feature in the up movement. Okay, so that's the main point. uh, so it tells you that thing. So if the variance is high, obviously it is important feature, right? Because a certain set of values of the feature means that the ETF will go down, and the certain set of features will say that the ETF will go up. Okay, so that is your F statistic. And you see the screenshot of my code here, and I have shown where from you can download all these modules. Thanks for being patient till now. And the next is the hyper parameter tuning. In the hyper so now we have selected features, sorry, I will go from start. We selected data, then we did some feature engineering, and then we selected features. Right now we have selected now 20 or 21 odd features out of 106. Okay, we took average of all these scores and determined the what features we need. you I just take average. Okay, each one of these methods give you one score. Okay, and you just sum all these four scores or ranking and just divide by 4. Okay, then that gives you like average ranking. And this also helps with the hyper fitting sorry overfitting perspective. Okay, and now the next point, the hyperparameter tuning. Okay, now you know your features, but you don't know parameters of your models. If you see one XGBoost model use so many parameters. It has estimate number of estimators, number of trees, and the maximum depth and learning rate, and subsample and subsample by tree. So this is nothing but number of trees. Maximum depth is how much deep your tree can go. Okay, it should be less. Okay, you should try to keep it to 3 to avoid overfitting, just for that. And number of estimators should not be too much also. Learning rate should be less to avoid overfitting, because if it is higher, then your model is prone to overfitting. Okay, subsample should not be 1 or even 0.9. Okay, to avoid overfitting. And so first stage, how did I search? Okay, there are so many things you want to try. Okay, there could be like thousands of different combinations of these parameters. So, and you have only finite time and finite resources. So what you do, you do one randomized search CV. Okay, so it just randomly picks some configurations from this list, which you see my on screen. Okay, and then it runs the model on these, and tracks the performance of each model for each of these configurations. So that's your randomized searched CV. And you note down different you get a hold of the best configuration. So that's the main thing, you get hold of the best configuration. You plug your best configuration in grid search CV. Okay, so I have given one example here. Okay, so all this document as well as the code I have pasted in the GitHub. In the end of this document there is a link to the GitHub library, and you can see this document as well as the code. Then the next point is this number of estimators. Okay, sorry, I'm just going too fast. Then you plug in those estimators that you figured out in the previous step in the randomized search CV. You plug in there and give some width. Okay, if you found a number of trees or a number of estimators to be 50, then okay, let's search 40, 50, 60. Okay, or maybe 30, 40, 50, 60. Just giving you one example. Or the max depth was like 3, then okay, let's do 2, 3, 5. Okay, give a width, give some option on the both directions of the best estimator. Do a like this time more like localized search. Localized, if the randomized search was like okay, I want to see all the universe, but only a certain sets of configuration from this all this broad universe, then the grid search CV is like localized search uh, to get the best parameter. Then you fit your model, which is again same for random search and the grid search, and then you figure out your best estimator. This is my model, guys, XGBoost. in simple machine learning algorithm, and it can train sorry, hundreds of decision trees sequentially. So this is important. Sequentially. Sequentially means one model improves on the performance of the previous model. If one model runs one relationship well, and if it makes a mistake in the prediction, then the next model can pick that mistake and try to fix it. They try to minimize prediction errors. Yeah, and they are very good at capturing non-linear relationships. Okay, and then the VIX, there are, you see in the financial markets there are lots of non-linear relationships. There are credit spreads. So they are good at capturing those relationships. But the main point is that they are also prone to overfitting. So we need to take care of that. Uh, so then the next point is time series split. Okay, so this was my model. You must be thinking, what is this new thing called time series split? Okay, obviously when you want to set aside your test data, you don't want to train on your test data as well, right? Because if you train your model on the test data itself, then your performance will be very good for your model. It might even achieve like 90% or 80% accuracy, just one example. But on the out of sample testing, it will give very bad results, very bad, worst. And why should we avoid it? Because you just don't want your model to see the out of sample data. You just don't want to see your test data. You only want to use your test data to validate, okay, how good your model is. Okay, so that's the main point. So yes, actually, you split the data using not this function. This function is actually used in creating. Okay, there's a good diagram here. Oh yes, there is a diagram. And it creates folds. This function creates folds, and you see here it created 4 folds, and four splits were 5 here, but here you see here here are 4 folds. I picked it from this site, and it trains on this portion of the data and tests on this portion of data, if assuming this is a time series. And then again in the next iteration it trains on this much, and so it creates 4 folds. And so this is it. Okay, it creates 4 sets of data and gives you the best parameter. It gives you the best parameter. Yeah, the main point is that if you see that in each of these validation, train set train set is different and test set is different. Okay, so this is now this is the validation data. It is not the actual test data which I have kept aside. So this is one way of doing validation plus training on one model in a single go. Okay, so it is the same thing that I showed you here, randomized grid search CV and grid search CV. So this is passed here, and so that's how it goes. Uh, so now I got 58% accuracy in the training and validation data set. Okay, using this method, where I trained on some part of the data, then tested on some part, then trained again on the bigger portion, then tested on next portion, then trained again, tested on next, trained again, next. You see, I never saw the test data. If you see this hierarchy, I never saw the test data in this one, never saw. This is called out of sample testing. Now, okay, so these are the best parameters I found. These are now you must be wondering, okay, did I overfit my data? Did I overfit my model? Let's see how much overfitting is there. So this is good data, subsample 0.9. It is actually good. I told you, right, subsample has to be less than 1. Okay, this is 0.9. I used some L2 regularization, And then max depth is 4. Okay, my tree is deep. Okay, it is overfitting moderately. Number of estimated 250. I did not use early stopping, which I get to it. I will get to it, the early stopping. Okay, so it is one method of avoiding overfitting. Okay, now these parameters, I could have done better. So they are no L1 regularization, and learning rate is aggressive. So you see out, I will rate myself 6 out of 10. There is a moderately high probability of overfitting. Okay, so I think that's the reason I got only 49% of accuracy. Okay, um, in predicting the movement, but the main point is that I wanted to show you that I got there is one more very good use of my model. I wanted to show you that. Please be patient. So I did not want to use this model to predict whether the stock ETF will go up. Actually, I wanted to predict whether it will go down or not. Okay, I will show you why it is very good in that. Okay, I have shown you already. Recall measure of 78%. It is uncannily good in predicting down movement. Okay, I did not tell about this. You can save your model in job lab. You don't need to train again and again before you want to predict. Okay, you can save your model, and then next time just give it some prediction data and it will predict. But the main point is that, okay, see, 78% accuracy in the downward prediction. You see the recall 0.78. Awesome. And so this is the formula of recall measures. You see, I'm capturing 78% of down movements. If the ETF would go down 100 times, then I will capture 78 times out of that. Sorry, my model, not me. It will capture 78%. That's awesome. Okay, it is a risk management uh, panacea. Uh, that's really good. Okay. Uh, what we can do next is try to figure out how did the model learn to be so good. Okay, to be at figuring it out when the index will go sorry, ETF will go down. Okay, that is the next exercise we can all undertake. How did this ML model learned this technique? How did it get calibrated in that way? uh, Apart from that, there is nothing noteworthy about this model. Okay. And its accuracy is less in the up movements. It is very less in the up movements. Okay, it is very bad model, but its only saving grace is that it's very good in predicting downward movements. Very good risk management tool. Okay, you may not earn a lot of money, but you will be a good risk manager. Or you can earn a lot of money if you just short the ETF. When you see that it's 70, when you see that it predict down, so I believe it will be correct 78% of time. So some way to make money there. So if you want to see where it is on the GitHub, this is the link, and if you click it here, so this is my code. If you see, you can, there is one readme as well. This is the readme, and this is the code. This is the code. This is the same code that I showed you. Extract the ticker data, then this feature engineering code. Okay, I showed you this Excel, right? So I created using this code only. So try your hands on it. And there is a feature selection code. I used those 4 methods that I told you, right? Mutual information, RFE, and that other 2 methods, permutation plus there was one more method, yeah, F statistic. And you can actually run your hand in this code and try to, so okay, this is it. This is it. This is the method that I used. And then there is a hyper tuning step. Hyper tuning, figuring out the best parameters for your model. Okay, this is the hyper tuning step. It has the same randomized grid search CV and grid search CV method. and that train test split method to create those 5 folds. And then okay, model testing. Then after that, what you do, you just give it the data you need and you test it. That's all. Give it the data, you test it, and then you get this what I was showing, this thing, final validation on the test data. You will see 0.78 and you will say, whoa, that's great. So yes, it catches 78% of the fires. It can, that's a good thing, because this these credit indices, sorry, this credit ETF, HYG or JNK, so they do predict, they do say what is, tell what is the broad market consensus on the movement of high yield credit. Okay, so they can tell you about a credit cycle. So this model can also be used to, okay, advise what is the next movements in the credit cycle. Are people putting money into HYG or other high yield credit ETFs, or are they pulling money out? Okay, and it is a very good model. Again, you can go through it. And then there are some other enhancement options. I wanted to use early stopping but could not. Okay, but could not, because you see this is temporal data, time series data is, it has different market regimes even after year 2020, the testing period which started after 2024 or 2025. Its volatility was different from the period before it. Okay, so my model did not train enough. Yeah, if I tried to do early stopping in my testing, or the validation stopped after 1 or 4 iterations, so I could train only 1 or 4 trees. So no, and I was expecting around one, maybe at least 250 trees or estimators. Okay, so I tried a lot, could not train more than 1 4 trees. So after that I gave up, but it is a good exercise, I may pick it up later. Then the root cause and solution 5. This is the root cause of it. Okay, you can go through it, but it's again the same thing, regime aware validation strategies. Okay, or in simple approaches, we can use some more approach, regime aware, uh, volatility aware features. And uh, and these and one, the most important thing, the disclaimer. So this is not an investment advice, this is educational and research purpose video. All this content is only for educational and research. It is not an investment advice. Please use, if you want to use this model for your work, okay, investment work or risk management work, please use with caution. Okay, it has to be properly back tested and validated. It is validated, but yes, again, it's not an investment advice. Past performance is not a guarantee of future performance. Okay, thanks all, have a great day. Thanks for watching this video. Bye.